Hey guys, this is going to be objective 24. We are going to solve trig equations. You will need your unit circle, so I highly encourage you to get out your unit circle. All right, let's look at example 1. So the first thing we're going to do when we solve is we're going to isolate the trig function. So I am going to move the 1 over, and I get 2 sine of x is equal to 1, and then I'm going to divide by 2. So the sine of x is equal to 1/2. Okay, now I'm not done. I am solving for x. I'm trying to figure out when the sine of the angle is equal to 1/2. Well, if you go to your unit circle and look, the sine is the y coordinate. So I want to look on my unit circle, and I want to look when the second coordinate, that is your y coordinate, x comma y, is equal to positive 1/2. So if you're looking, I think x could be pi over 6, which would be your 30 degrees. So if you look at that, the coordinate point is square root of 3 over 2 and positive 1/2. That means the y coordinate is equal to 1/2. Okay? And then I also think there's another spot. If you go to the second quadrant, it would be 5 pi over 6. So that would be your 2 answers. Okay, now if you go all the way around the unit circle, there's no other place where the y coordinate is positive 1/2. Okay, in the third and fourth quadrants, those are negative 1/2. Okay, so there's only 2 places where it is positive 1/2, at pi over 6 and 5 pi over 6. Okay, I do want you to know that on your worksheets and your practice, you'll either see that you're looking for x from 0 to 2 pi or from 0 to 2 pi. And it's just one's written in interval notation and one's written in set notation. Basically what this means is we're going to look at our unit circle and we're going to go all the way around one full rotation. But notice this, that it can be equal to 0. So like if you get a point and it's right here, okay, like for example when the cosine of x is equal to 1, okay, that would be right here. Here's the question. That's 0, but that if you go all the way around, that's also 2 pi. So do you use the 0 or do you use the 2 pi? And we're going to use the 0. It can be equal to 0, but it's got to be less than 2 pi, which means the 2 pi is not included. In set notation, the bracket means that it's included. So the 0 is included. The 2 pi is excluded. Okay, that's just what that means. Okay. All right, so let's go to example 2. We're going to isolate the trig function. So I'm going to move the negative 3 over. And then how do I get rid of a square? I'm going to take the square root on both sides. So when I take the square root, these cancel, and I get the tangent of x. And when I take the square root of 3, if I'm taking the square root on both sides of the equals, then that's going to be plus or minus square root of 3. Okay, if you're taking the square root on both sides. So I want to go to my unit circle. And how do we get tangent? We are going to take tangent is equal to the sine divided by the cosine, correct? So that would be the y divided by the x. So I want you to go and look on your unit circle and look at when you divide the y coordinate by the x coordinate, when can you get positive or negative square root of 3? So the first one I see would be pi over 3. And I'm going to show you because that coordinate is 1/2 and square root of 3 over 2. So if I divide that, I'm going to divide square root of 3 over 2 divided by 1 over 2. The 2's cancel, and I get square root of 3 over 1, or just square root of 3. Okay, so that would work. Okay, I'm also going to get 2 pi over 3. And if you look at that coordinate, it's the same coordinate, it's just the x is negative. And you want the negative because it's plus or minus. So when you divide it, it'll be negative square root of 3. Then if you look on around, that same coordinate would be 4 pi over 3. All the way around, keep going, it would be 5 pi over 3. So I think at all of those places, the tangent, when you divide the y by the x, it would be equal to plus or minus square root of 3. Okay, so I'm going to isolate the trig function. So I'm going to move the 2 over. And then I'm going to take the square root. Now, am I taking the square root on both sides? Yes, I am. So I'm going to get secant of x on this side because they cancel. And then if I'm taking the square root on both sides, then it is plus or minus square root of 2. And I know what you're thinking. You're thinking, wait a minute. On example 1, we only did positive a half. But here's the thing. Did we take a square root on example 1? And we did not. So this one is just positive a half. But on the next 2 examples, we took a square root on the left side and the right side. Okay? So this would be secant of x equals plus or minus square root of 2. But you can use it from the secant, okay? Or I would go back to your original trig function. So we know secant, if we take the reciprocal of secant, so if I did 1 over secant, that would be cosine of x. And so if I take the reciprocal of this, I'd have to rationalize it. It would be plus or minus square root of 2 over 2. So basically, I just flipped it and took the reciprocals of it. So I'm looking, this is cosine, so this is the x coordinate. When is the x coordinate positive square root of 2 over 2 or negative square root of 2 over 2? So that would be at pi over 4. That would also be at 3 pi over 4. And everybody says, but that's negative. Yes, because I want the negative. I want the positive and the negative. Go down to quadrant 3. That would be 5 pi over 4. And quadrant 4 would be 7 pi over 4. So all of those answers should work. Okay? All right. What's different about example 4? Can't really isolate it because I have a cosine squared x and a cosine x. So what can I do with it? And let's just look at it in terms of algebra. Let's take the cosines out for a minute. Let's just look at it as 2x squared minus 7x plus 3. So if I looked at this, I would say we could factor that. It's a trinomial. So we could factor this into 2x and x. We could factor this into minus 1 and minus 3, I believe, because that will give you negative 6x, and that will give you minus 1x, which is negative 7x. Okay? So it's the same thing, except I've just got some cosines in there. So we're going to factor this into 2 cosine x and 1 cosine x. And I'm going to factor this into minus 1 and minus 3. Okay, so hopefully that made sense. And that should work out. If you FOIL that back out, it should work. So, remember when we solved quadratics and it was set equal to 0, what we did? We took each factor and we set it equal to 0. So 2 cosine x minus 1 equals 0. So if I moved this over, 2 cosine x equals 1. and divided by 2. So cosine x would equal positive 1/2. Is it plus or minus? No, it is not, because I did not take a square root. It's just positive square root, or positive 1/2. Okay. Then if I take cosine x minus 3, and I move the 3 over, cosine x would equal 3. Now, we're not done. We got to figure out what x is. So I'm going to first go to my unit circle, and I'm going to look at where the x coordinate is equal to positive 1/2. And that would be pi over 3. And that would also be, we're not looking at quadrant 2 or quadrant 3 because those would be negative. So I'm looking at quadrant 4. I see 5 pi over 3. So that's where x would be positive 1/2. Now, if I look at cosine x equals 3, where on the unit circle would the x coordinate be 3? Like, let's think about this. This goes out to 1, this goes up to 1, this goes out to -1, and this goes down to -1. Where's 3 on the x? 3 on the x would be way out here, would be 3, if this is 1. And 2 would be somewhere here in the middle. So where is 3 on the unit circle? And it's not. Okay, don't forget. If you did, like if you used your calculator for this, and you did cosine to the -1 to solve this, like those cancel, and you did cosine to the -1 of 3, you'll get an error. Because the sine and the cosine, because of the unit circle, cannot be greater than 1. So this one is just not possible. I'm actually going to throw a big red X over it. It is not possible. Okay, but those two answers that came from this over here are possible. So x could be pi over 3, and x could be 5 pi over 3. You just have to throw out the second one because it's greater than 1. Okay. So normally we set everything equal to 0. So what would you move? Would you move the 1 plus sine x over, or would you move the 2 cosine squared x over? And I hope you're remembering, I always like my squared term to be positive. So I'm going to move all of this over here and set it equal to 0. So 2 cosine squared x minus sine of x minus 1. Now here's the issue. Can I factor that? And I can't, because I don't, if it was like all in the same trig function, I could try to factor it. Like if it was all cosine, I could try to factor it. Or if it was all sine, I could try to factor it. Okay? But I cannot. So I need to try to figure out, how can I get this all, like maybe could I somehow change the cosine squared x and make it sine so that they would match? And if you look at your Pythagorean identity, could I solve this for cosine squared x? And you could. You could move the sine squared x over, and you get 1 minus sine squared x. Okay, so what's cosine squared x equal to? 1 minus sine squared x. Well, okay, so I can plug in 1 minus sine squared x minus sine of x minus 1 equals 0. So this would be 2. This would be minus 2 sine squared x minus sine of x minus 1. So 2 and -1, that would be -2 sine squared x minus sine of x. I'm going to combine these two right here, and that would be a plus 1. Now, everybody's like, Ms. Corns, I thought you said you didn't like your square terms to be negative. I don't. So if it is okay with you, I'm going to come up here, and I'm going to erase all this so I have room to write. I got all these little pieces. You can either take all of this and move it to the other side and set it equal to 0, or if you do that, what's it going to do? It's just going to change all the signs. So if you wanted to, that would work. So 2 sine squared x plus sine of x, it's changing all the signs, minus 1 equals 0. Okay, so now it's all in the same trig function. So now I could try to factor that, just like I did example 4. So if I were you, it's trinomial, hit pause and see if you can work it from here. So if you're back with me, I'm going to factor this into 2 sine of x and sine of x. And I'm going to factor this into plus 1 and minus 1. Because if you FOIL this out, that would be, so 2 sine x times sine of x is 2 sine squared x. If you do the outer, that would be positive 2 sine of x. And if you do the inner, that would be minus 1 sine of x. And negative 1 times 1 is this part. And if you add these two, you get what's in the middle. So that works. Okay? So what do we do now? We take each factor and we set them equal to 0. So 2 sine of x minus 1 equals 0, and sine of x plus 1 equals 0. And I'm going to solve them. So I'm going to move this over, and I'm going to divide by 2. So the sine of x, and it's not plus or minus because I did not take the square root on both sides. So it's just positive a half. And then here, when I move this over, this would be the sine of x equals negative 1. So I'm going to go to my unit circle, and I'm going to look, where is the y coordinate equal to a half? So x could be pi over 6, and x could be 5 pi over 6. If you look at those coordinates, the x, or the y coordinate is 1/2, positive. Where is the sine? Where's the y coordinate negative 1? And that would be down at 270, so at 3 pi over 2. So there should be your 3 answers. Okay? And there's no other place on here where the sine is equal to negative 1. All right. I'm not going to do example 6. We're going to skip some of these. And I'm not going to worry about example 7 or 8. I am going to look at example 9. Okay, so let's look at this one. So you could look at it and just look at where on the unit circle, where can I take the y coordinate and subtract, the tangent is the y minus the x, or y divided by the x. Where could I take them and subtract them and get 0? Or you could set them equal to each other. You could move this over. And so here's what I want to know. Where is the y equal to what you get when you divide the y by the x? Because that's what the sine and the tangent are. So if you look at your unit circle, I think that answer would be at 0. Because let's look at that coordinate. It's 1, 0. So let's look at it. The sine is equal to 0. And the tangent would be equal to the y divided by, so 0 divided by 1, which is 0. So they're both the same thing. Okay? And I also think you get that when you go over to pi. Okay? Because that's negative 1, 0. Now, is that true for pi over 2? Is that true for the reverse of that? 0, 1. And no, that is not, because the sine would be 1. What's 1 divided by 0? And that's undefined, so that doesn't work. Okay? So it's just 0 and pi. And remember, we're using 0, not 2 pi. Okay? It can be equal to 0, but it has to be less than 2 pi. Okay, so this is the last one we're going to look at. And I would do the same thing here. Let's just move this cosine over. And let's just look at our unit circle. Tell me, the sine is the y, and the cosine is the x. Where are the x and the y the same thing? The exact same thing. And that would be at pi over 4. That would also be at 5 pi over 4. It would not be in the second quadrant or the fourth quadrant because one's negative, one's positive. That's not the same. It's got to be the same thing. So in quadrant 1, at pi over 4, it's square root of 2 over 2 and square root of 2 over 2. And in quadrant 3, it's negative square root of 2 over 2 and negative square root of 2 over 2. So sometimes when you get them like this, you just have to look and see where it makes sense on the unit circle. So I'm going to stop right there.